Hello and welcome to the Dig It, Check It video guide. My name is Amy Way and I will explain how to use our simulation tool for assessing the effectiveness of a test pitting program in the detection of artefact sites. This is free to use and we ask that you cite the associated paper should you decide to use it in your work. First of all, I'll show you how to create the 3 shapefiles in ArcGIS which define the survey properties and are then loaded through these buttons. And you can see here the parameters which have been loaded in this model. The world is this boundary here, the survey area is this line here, and the test pits are each displayed with their length and width properties. I'll then go through selecting the site properties, running the simulation and inspecting the results. So first of all, let's open up ArcGIS, and here we can see our 3 shapefiles. First of all, we have the world, which is, we'll just close that, the world which is this shapefile here. If we open up the attributes, you can see that it's a very simple polygon. It doesn't have any features and it doesn't need anything added to it beyond what ArcGIS produces. The second shapefile is the survey area, and that's shown here as this blue zone. And in this example, I've created a survey area which has a hole in it. In this example, there was a disturbed area which wasn't surveyed, and so it was excluded from the area which has been surveyed. If we open the attribute table, it's slightly more complicated. It has one field which I've added called SA, and it's really important that when you add this field, so firstly you have to add this field, and secondly when you add it, it has to be called SA with capital letters, because otherwise NetLogo, which is case sensitive, won't be able to find it. If we look at the properties, you can see that it's a string, and yes, we've got the capital letters there, SA. And then once the field's created, it's just a matter of entering the word yes in lowercase. And what that will do in NetLogo is it will separate out the area in blue which has been surveyed from the area around it and also within the hole which has not been surveyed. The third shapefile is the test pit file, and you can see here each of these is displayed as a point in ArcGIS. If we open the attribute table, there are 2 extra fields added. So we have, first of all, we have the ID field, the properties, and it's a long field, and keeping the ArcGIS ID is fine. It just has to remain as it is with the capital I and small d. And then the width and length have both been added as fields. And when you add the width field, it has to be, the type has to be double, because this allows you to put 0 point, puts the decimal point in, and again lowercase w for width. So the writing has to be exactly as it is shown here, and the same for length, small l, and the type again is double. So one of the properties of NetLogo is that the background squares are hard-coded in 0.5 meter length, and so that means that the width and length of the test pits has to be in 0.5 meter increments. So now our shapefiles are ready to export, and we do that through Data, Export Data. And the important thing here is that you export them to the same file, the same folder where your NetLogo model is stored. And we'll just give them a better name. So data, export data again, same folder, we'll call this SA. Data, export data, and this is the world shapefile. Okay, so now we've exported the 3 shapefiles, we're ready to go back to NetLogo and import them. And we do this firstly through the Load World button. This will bring in our world shapefile, which is here in the same folder as our model. And that sets the boundary of this window here, and which we can see the properties displayed here. So it's 107 meters wide, 129 meters long, and this immediately lets you know whether it's right or not. If these are wildly off what you expect, then you know that something's gone wrong, but in this instance they're right. Then we load the survey area boundary, which we've called SA, and that shows up here. And when this was imported, the field which asked whether or not it had been surveyed has now brought in the coding for all of this area to have been surveyed. So it's coded as surveyed yes, where this patch here is not surveyed and this here is not surveyed as well. And so when we come down to the site properties, we can decide whether we want to constrain the site centres to fall only within the surveyed area, or whether we want them to also fall outside in this area defined by the world. And lastly, we bring in the test pits, and we call those TPs. And so you can see here that while in ArcGIS they're displayed just as points, the properties, the length and width properties in the attribute table determine how the pits are drawn in NetLogo. So we can see that the pits have different lengths and widths. And we're then ready, having imported all of our survey parameters, we're then ready to determine the site properties, and we do that here. So the site diameter, let's say it's 20 meters, average density of 40 artifacts per square meter. The density distribution, we have the choice between these 4 distributions, and the difference between these is discussed in the paper. We'll go with uniform distribution. Clustering as well is discussed in the paper as to whether or not you want that on, and we will constrain the site centres to only fall within the surveyed area. The number of trial runs is the number of simulations, so the number of sites that's placed while the model runs, and the larger the model, the larger the number of runs, the better, the more repeatable the results, because it is trial and error. The smaller the number, the less repeatable the results are. But for the sake of making the model run quickly for the tutorial, I've set that at 20. But if you right click here, edit, you can then type in the number that you want. And if you're running this to actually find a result, you should put 1,000, but we'll put 20 just so that it runs quickly. And then we're ready to run the simulation, and that places the 20 sites randomly within the survey area to determine how many would be intersected and detected by the test pits that were dug. And these results are displayed in the lower part here under the results section. And so here we have the number of sites which were run in the model. We have 20 sites. The number of test pits that were dug, 12, and we have 60% as our intersection rate and also 60% as the detection rate. And the reason they're the same in this instance is because we have a uniform density distribution. So if we want to try a different distribution, let's go for cosinusoidal, and then we run it again, we'll have a difference here. And that's because the density in the middle of the site is higher than at the edge of the site. And so if the test pit intersects the site at the site's margin, it may not have a high enough density for at least one artefact to turn up in that test pit. And so that means 15% of the sites in this model were intersected, so a test pit fell within the boundary of the site, but they were not detected because the density was not high enough at that point. So that's the end of the tutorial. Remember to cite the papers when you use it, and thanks for watching.